Raw materials are sourced from certified suppliers to ensure consistent quality. For example, prime drinks might include electrolytes like sodium, potassium, and magnesium, along with other performance-enhancing ingredients such as branched-chain amino acids or vitamins. These ingredients arrive at the factory in large containers, such as barrels and sacks. Storage and handling are crucial. Raw ingredients are stored in temperature-controlled environments until needed. Automated systems track inventory levels, ensuring that fresh supplies are ordered and stocked on time. Computerized dosing and mixing come next. Precise amounts of each ingredient are dispensed into large stainless steel mixing tanks by automated systems. Computer controls ensure that the ingredients are combined in the exact proportions required for the recipe, minimizing human error. The tanks may include agitators or stirrers to ensure thorough mixing. After the ingredients are mixed, the liquid passes through a series of filters to remove any unwanted particles. These filtration systems might use microfiltration, ultrafiltration, or even reverse osmosis, depending on the beverage's formula. Filtration ensures the drink has a consistent texture and taste. To prevent microbial contamination and extend shelf life, the liquid is pasteurized. There are several types of pasteurization. Thermal pasteurization involves heating the liquid to a specific temperature, often around 70 to 90 degrees Celsius or 160 to 194 degrees Fahrenheit, for a short time to kill bacteria, yeast, and molds. High-pressure pasteurization, or HPP, subjects the beverage to high pressure instead of heat, which helps preserve more nutrients and fresh flavors. Some beverages may also go through a UV light treatment to further reduce microbial load. Many factories have blow molding machines that turn plastic preforms into full-sized bottles using air pressure. This is a common practice for plastic bottles, whether PET or HDPE. Glass bottles may also be produced in-house, though many companies opt to purchase pre-made glass bottles from external suppliers. Cleaning is essential before filling. Bottles are sterilized using various methods. For plastic bottles, this often involves spraying them with sterilizing agents like hydrogen peroxide or ozone. Glass bottles may be steam sterilized or exposed to UV light. Automated sensors ensure that no foreign objects or contaminants enter the bottles during the process. High-speed filling machines operate in a sterile environment, often under a laminar flow of sterile air, to prevent contamination. They can fill thousands of bottles per hour. The filling machine works by inserting a nozzle into the bottle that dispenses the exact amount of liquid based on volume or weight. The process is rapid and precise. For beverages sensitive to oxygen, the bottles might be flushed with nitrogen before capping. This process displaces oxygen in the headspace of the bottle, which helps preserve freshness and extend shelf life. After filling, the bottles move down the conveyor to the capping station. Depending on the type of bottle, plastic or glass, and the cap, the machine applies the correct closure. Screw caps, whether plastic or metal, are common for plastic bottles and are twisted on using high-speed rotary cappers. Crown caps are used for some glass bottles and are pressed onto the top of the bottle using a crimping mechanism. To ensure a tamper-proof seal, shrink bands or induction seals, which are thin aluminum foil layers on the inside of the cap, may be applied to some types of caps, particularly for health or sports drinks. These seals are heated using induction to fuse the foil to the bottle's mouth, providing an airtight seal. Automated labeling machines apply labels at high speeds after capping. Depending on the bottle's shape and design, labels can be placed on the front, back, or around the bottle's neck. Pressure-sensitive labels are pre-printed labels with adhesive backing. Shrink-sleeve labels are applied around the bottle and then shrunk to fit using heat, ensuring a 360-degree coverage of branding and product information. Vision systems inspect the placement of the labels to ensure they are aligned properly, with any misaligned labels resulting in the bottle being rejected. Finished products are stored in temperature-controlled warehouses before distribution. Modern warehouses use automated systems such as robotic pallet movers, conveyors, and automated guided vehicles to move products around and manage inventory. Computer systems track product batches, expiration dates, and stock levels to ensure that the factory can meet demand and rotate inventory efficiently. Once the bottles are palletized, they are loaded into trucks for distribution. Shipping logistics are often optimized using software that determines the most efficient route and schedule for delivery. Some beverage companies operate their own fleet of trucks, while others partner with logistics companies. For global distribution, products may also be shipped by air or sea to reach international markets. Artificial intelligence is increasingly used in beverage manufacturing to optimize production schedules, monitor equipment for preventative maintenance, and improve quality control through predictive analytics. IoT sensors on machinery provide real-time data on the factory's operations, helping identify bottlenecks, monitor energy usage, and prevent potential equipment failures. Automated robots are heavily used in various steps, from palletizing to loading and unloading trucks. Some factories even have robots that assist in handling raw ingredients. This automated, efficient process allows beverage companies like Prime Drinks to produce large quantities of consistent, high-quality products at a fast pace, ensuring timely distribution to consumers around the world. Eco-friendly packaging. In response to environmental concerns, many beverage factories are investing in sustainable packaging technologies. This includes the use of biodegradable plastics, recycled PET, and plant-based materials. For glass bottles, companies are exploring lightweight options that reduce the amount of raw material used. Smart packaging. Some modern beverage factories are experimenting with smart packaging that can include embedded QR codes or RFID tags. These allow consumers to access product information like sourcing details or nutritional content by scanning the packaging with their smartphones. RFID tags can also be used in warehouses for more efficient inventory tracking. Customizable packaging. Factories with flexible production lines can offer personalized or limited edition packaging. This might include custom bottle designs, limited-time graphics, or special promotions printed directly on the bottles. This is done using advanced printing technologies that allow for rapid design changes. Energy use monitoring. Factories are increasingly using IoT technology and AI to monitor and reduce energy consumption. Smart meters track the use of electricity, water, and gas in real time, allowing operators to identify areas where efficiency can be improved. Wastewater treatment. Beverage production often requires large amounts of water, and many factories have systems in place to treat and reuse wastewater. In some cases, this treated water can be used for non-product purposes like cleaning equipment or cooling systems, reducing the overall water footprint. Renewable energy sources. Many factories are transitioning to renewable energy sources such as solar panels, wind turbines, or bioenergy. These factories aim to reduce their carbon footprint by generating a significant portion of their electricity on site. Batch tracking. Each production batch is assigned a unique code or number, allowing the factory to trace the entire life cycle of the product, from raw material sourcing to distribution. This is especially important for quality control, as any issues like contamination can be quickly traced back to a specific batch and necessary recalls can be issued if needed. Regulatory compliance. Factories must meet strict regulatory standards set by government agencies. In the food and beverage industry, this includes ensuring that products are safe for consumption and meet labeling laws. Automated systems help monitor compliance with safety and hygiene regulations. Predictive maintenance. Using IoT sensors on machinery, factories can predict when equipment is likely to fail or need maintenance. This prevents unexpected downtime, as maintenance can be scheduled during off-peak hours or planned production breaks. Automated maintenance alerts. When machines detect abnormal vibrations, heat, or slowdowns, alerts are automatically sent to maintenance teams. These systems use AI to determine the root cause of problems and suggest fixes, minimizing disruption to production. Demand forecasting. AI algorithms analyze sales data, market trends, and even weather patterns to forecast demand for beverages. This allows the factory to adjust production schedules to avoid overproduction or stockouts. Supply chain optimization. AI is also used to optimize the supply chain, ensuring that ingredients arrive on time and production materials are available when needed. Machine learning can analyze patterns in ingredient usage and identify the best times to reorder supplies or source alternatives if shortages arise. Real-time production adjustment. Some factories have AI systems that adjust production parameters in real time based on feedback from sensors. For instance, if a certain ingredient's concentration starts to vary slightly, the system can automatically adjust the mixing process to maintain the correct formulation. Automated palletizing. Palletizing robots take finished bottles and arrange them onto pallets in an optimal configuration for shipping. These robots can handle a wide range of packaging types and weights, ensuring that products are packed securely and efficiently. Automated Guided Vehicles, AGVs. In modern beverage factories, AGVs transport raw materials, ingredients, and finished products across the production floor or warehouse. These driverless vehicles follow pre-programmed routes and can navigate around obstacles, helping streamline internal logistics. Autonomous Cleaning Systems. Robots equipped with sensors can clean factory floors and machinery, ensuring the production environment remains hygienic without requiring manual labor. These robots often operate outside of working hours, reducing disruption to production. While much of the production process is automated, human operators still play a key role in monitoring the systems and intervening when needed. Workers are responsible for overseeing equipment, conducting manual quality checks, and responding to system alerts. This hybrid approach allows factories to maintain high levels of efficiency while ensuring the flexibility that only human judgment can provide. Operators use human-machine interface panels to control and monitor machinery. These interfaces provide real-time data on production status, machine performance, and any anomalies. Touchscreen panels with intuitive graphics make it easier for operators to adjust settings and troubleshoot issues. Some factories have specialized lines for small batch production. These are used to test new flavors, formulations, or packaging designs before scaling up to full production. This allows beverage companies like Prime to quickly develop and refine new products based on consumer feedback or market trends. In some factories, lines can be reconfigured to accommodate different bottle sizes, packaging types, or beverage formulations. This flexibility enables rapid shifts in production based on demand.